Hello, welcome to Simplifying Radical Expressions with Variables. Last week you got to work with Mrs. Goulet on simplifying radicals when you only had numbers. But this week we're going to throw variables in there because of course this is algebra. We like to have variable quantities. So let's start off looking at this first problem. We have the square root of 27x squared. Last week you looked at what the square root of 27 would be if we simplified that. So let's start off with that. Well, first thing we can do is we can break apart 27 into a perfect square number, like 9, times the rest, which is the square root of 3. 9 times 3 is 27. Then we have to handle how to handle square root of x squared. Now, we're looking for perfect squares, kind of like 9 is a perfect square. Now, if you look closely, x squared should seem like a perfect square. Let's look closer. The square root of x squared is really the square root of x being squared. So yes, x squared is a perfect square. So we can write that as the square root of x squared. Now we have three radicals, two of which we can simplify. The square root of 9 is 3. The square root of 3 stays as just the square root of 3. And the square root of x squared is really, look up here, the square root of x being squared. So the square root and the square cancels out. And what are you left with? Yes, just x. The last step we need is to put all the things outside the square root together. So 3 times x is 3x, and things on the inside together, which is the square root of 3. So our answer is 3x times the square root of 3. Let's move on to another one. Number 2. We can break that apart, looking at 18, into the square root of 9 times the square root of 2. 9 being a perfect square. When you break these apart, remember, one of the two factors that you break it apart into must be a perfect square. And 9 is the largest perfect square factor that divides into 18. And then let's also look at b to the fourth. Now, if we look closely at the square root of b to the fourth, b to the fourth is really b squared squared. Why? When you take a power and you raise it to another power, you multiply the powers. So 2 times 2 is 4. So what we're really squaring on the inside is b squared. So b to the fourth is a perfect square. So the square root of 9 is 3. We still have the square root of 2. Sadly, that has to stay inside the square root sign. And the square root of b to the fourth, remember, is what are we squaring? What are we squaring to get b to the fourth? We're squaring b squared. So the square root of b to the fourth is b squared. So 3 times b squared is 3b squared. And we also have it times the square root of 2. Now I don't know if you've noticed this, but there's a little trick to this. Look what happened to the power here when we took the square root. 2 became the power of 1. 4 became the power of 2. Think about that for a moment. When you deal with variables, whatever the power is on the inside, when you take the square root of it, it always gets cut in half. Again, you take half of the power of the variable to get the new power on the outside. That's great and all. But what happens if you don't have something you can cut in half? We can't cut 3 in half nicely, can we? No, we can't. So we have to do a little bit of work with that. So let's take a look at the square root of 18. That is the square root of 9 times the square root of 2. And x to the third. We want this to be even because even numbers we can cut in half. So that power is not even. But what we can do is we can pull one of those x's away. If we take one x away from 3, x to the third, we're left with x squared. So whenever you have that odd power, you always want to pull one of them away and then decrease the power by 1 to get that even power you need. So now we have the square root of 9 is 3. The square root of 2 is just the square root of 2. The square root of x is the square root of x. And the square root of x squared, cut the power in half, and you're left with x. Things on the outside of the square root go together. So 3 times x is 3x. And things on the inside of the square root go together. So you're left with the square root of 2x, which is our answer. 3x times the square root of 2x. Let's take a look at another one. How about number 6? Uh-oh, large number. But you notice I see 75 in there. And what divides into 75? 25. So 25 divides into 75. It'll also divide into this 175. So it's the square root of 25 times the square root of 7. X squared, yeah, even power. That's a perfect square. That can stay inside. But y to the third is not an even power. But if we pull one of them away, you're left with an even power of y squared. I know it looks like a lot of square roots, but this will help us to organize things. So what's the square root of 25? 5. The square root of 7 is simply the square root of 7. The square root of x squared, we can take the square root of that and get x. The square root of y we can't do anything with, so it has to stay on the inside the square root of the y. And the square root of y squared, that's a perfect square. Cut the power in half to get y. Oops, I put y squared. Yeah, even teachers make mistakes too, but you know what I got? I got a little eraser here. Yeehaw, look at that. So now we have 5 on the outside, x on the outside, and y on the outside. So that gives us, if we multiply them all, 5x, y, and then the remaining pieces are inside the square root, so they stay on the inside. So we have times the square root of 7y. So, yes, it looks like we're breaking things apart a lot, but what we're really doing is organizing individual pieces that we can simplify. Here, 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 and here. And if you keep that organized, your work organized, it'll be nice and neat. Okay? Let's move on. How about this one right here? Square root of 32, x squared, y squared. Well, 32 is not a perfect square, but you know what is? Yes, the square root of 16. And 16 times 2 gives us that 32. So we break 32 apart into 16 times 2. X squared is a perfect square, which is nice. And so is y squared. So the square root of 16 is 4 times the square root of 2. The square root of x squared just becomes x. And the square root of y squared is just y. Outside, outside, and outside. So on the outside we should be left with 4 times x times y, and then on the inside we're left with the square root of 2. Alright, what happens if we have numbers on the outside of our square root? Not to worry about that. This negative 7 is negative 7 times. There's a multiplication dot that we just don't see. So we have negative 7 times. Let's break this square root of 98 apart. Well, what divides into 98? That's a perfect square. The square root of 49. 49 times 2. And the fourth, again, that is a perfect square, which is nice. We know it's a perfect square because it's even power. So we can keep that in there by itself. So we have a negative 7 times square root of 49 is 7 times the square root of 2 times, remember, whenever you have even powers, cut the power in half. So what's half of 4? 2. You notice the square root sign disappears once you take the square root. Don't forget that. So negative 7 times 7 is negative 49. We also have an n squared. And you're left with the square root of 2 on the inside. So our answer is negative 49 n squared times the square root of 2. The last one we're going to take a look at is this one down here, because it's a large number. The great news about it is 256 is a nice perfect square. We have 4 times the square root of, as square root of 256, u to the fourth is a perfect square, and v is not, so that's in by itself. So 4 times the square root of 256 is 16. Square root of u to the fourth is, cut the power in half, u squared, and the square root of v. So 4 times 16 is 64, u squared, square root of v. And hopefully that's enough to help you out. Hopefully you've enjoyed this video and you'll look in on the next one that'll show up soon. Have a wonderful afternoon and good luck with your homework.